Okay, does everybody have the paper? Nope. Okay, phones away, please. All right. So same rules apply. Let's maybe put them up here over to the side. Remember that I have an open circle if there's no equal sign, and with an equal sign is a closed circle. Okay, are we ready? Okay, and remember we still want to make sure that we have the variable on the left side so that graphing is a little easier. What should we do first on this one? What should we do on this first step? Yes. By doing what with the 9? Yep, subtract. Nothing happens to my inequality sign. What's 21 minus 9? 12. And then how do I get rid of the 4? Good. Does my inequality flip at all in this case? No, because the number that I'm dividing by is not negative, so it stays greater than 3. Okay? Somebody give me a number greater than 3 that we can plug in.
6.
6. Okay, so if I put in a 6 for the x, is that greater than 21? Well, yeah, because we can look at that and say, well, I know 6 times 4 is 24, and that's bigger than 21. 9 plus 24, which is 33. Is 33 greater than 21? Yes, so it works. Okay? And then if we wanted to graph this, would it be an open or a closed circle? Open, yeah, because there's no equal sign. And what way are we going with it?
Right.
Yeah, it's pointing that way. Good. Questions on that? Just solving equations just like we did before, except we have an inequality sign that sometimes has to flip. Okay. We have a community garden that you want to fence. You want to fence in the vegetable garden that's adjacent to your friend's garden. So what does adjacent mean? Next to. Okay? You have at most 42 feet of fence. What are the possible lengths of the garden? Okay, so here's your garden. Your friend's garden is next to it, right? Adjacent. You have 42 feet of fence. So if we know this is already 12 feet, then we know we've got, well, that's not going to show. We know we've got 12 feet from here to here, right? 12 feet here. Okay, so what, we could adjust this though, right? We could make it shorter. So how many feet of fence do we know? If we're building a fence around the vegetable garden, then that means I'm using the perimeter, right? I'm adding up all the sides. So how much fence have we already used just to get the ends?
24.
24 feet, right? So we've got some number of feet that we can use for our garden, plus the 24 feet that we know we've got to use if we want to keep it adjacent to our friend's garden. And what am I gonna use for my inequality? If I have at most 42 feet of fence. Can I use more than 42 feet? No. So can I use 42 feet? Yeah. So less than or equal to 42? The equal comes in when you think, okay, can I use 42 feet, or does it have to be only something less than that? Okay, so now if we just subtract, what's 42 minus 24? 18, does that sound right? Sure.
You doubled the
Yeah, so the length, I know I've got, this will tell me that I can use anything 18 feet or less, right? For this length up here. I've got 18 feet to use here. So they're asking, what are some possible lengths of the garden? I can't have a garden 18 feet wide, because that'll take 2 of these. So what's the longest fence I can have across here if I can't use any more than 18 feet of fencing? What's half of this? If I wanted
9.
right, because I've got to use 18 feet for top and bottom. So that would mean 9 we could use. 9 would be the most, right? So 9 or anything less than that would be the length of our garden. Okay? So let's write that down, because the way we solved it gave us a total, right? So less than or equal to 9 foot length for the garden. Okay? That makes sense? That's something that you guys do in your head without consciously using algebra. Okay, now down here, what should I do first with this inequality? Sam?
Distribute the 3
Yeah.
to 1.
Yep, and don't forget to do it to the 1. Some of you guys are still forgetting to do, you do 3x, and then you forget to distribute to the 1. So that gives me 3x plus 3. Okay? Now, before I move anything, what's the best thing to do with this side over here? What can I do over here? Yeah, combine like terms. Don't start moving stuff. You get stuff on too much movement. What's 3x minus 4x? Negative 1x. Remember that I'm not subtracting 3x or adding 4x. I'm just putting these together. I have a positive 3 and a negative 4. Remember, you don't need that 1 there. I like to put it there just to remind myself. Okay, then what next? What can we do with the 3? Yep. Negative 5 minus 3. Good. I heard it. And then I don't want that negative on my x, remember? So I just have to divide it off. But what happens to this when I divide by that negative? Switch it, yeah. So x is now less than or equal to positive 8. Okay on that? Phones need to be away, please. Make sure you have these notes down. Okay, everybody got this? Okay. All right, now we've got variables on both sides. So, what movement should we do first? Minus 3n, okay. Because these are on different sides, now I do want to do the subtraction to move it over. Okay, it's on the other side of that inequality, so I do want to move it. 6n minus 3n. Yep. Okay, now we want to get rid of that minus 1. Yep. And divide by 3. Does the inequality switch here? Did I divide by negative? No. So it just stays. Okay. So what are some numbers that would work in there? What's a number that'll work? Anything greater than 3. Yeah, 6, 7. All of those will work. Oh, I used Christmas colors. Okay, what should we do first here? Distribute. Yep, we want to get rid of that. Two goes to everything. Okay, does anybody notice something on this one? The sides are the same. Good. So what's going to happen if I subtract 10 or add 8a on both sides? What's going to happen? That gives me 0. This gives me 0. So I'm left with 10 is greater than or equal to 10. Is that a true statement? 10 is not greater than or equal to 10. It is, right? If I didn't have that equal sign, then yeah, that wouldn't be true. 10 isn't greater, but I have the equal sign, so it can be 10 also. Okay, so this means when your variables drop out completely and you have a true statement here, then you can just write all real numbers. That means no matter what I put in for A, it's going to work. Okay, I can pick anything and it'll work. Or there's that fancy R. It also is a symbol for all real numbers. Okay? Only if this is a true statement. This has to be a true statement in order to get all real numbers. Okay? All right. How about over here? I don't have any distributing to do, but can I combine like terms here? Yeah. because I've got a 7m and a minus, I could put a 1 there, minus 1m. It looks like we might have something drop out here. If I get rid of my 6m, but something different happens on this one. So my m's are gone, right? They dropped out. Now I have -5 left on this side and a 7 left on this side. Is that a true statement? No, -5 is not greater than 7. Okay? So if it is not a true statement, not true, is no solution okay for you? Okay. So then you're just going to put no solution. That means no matter what number I put in there, I can't work it down and get anything that's going to work. Okay? That's if this inequality that you end up with is not true, then there is no solution. No number will work in there. Do you guys see the difference? In both cases, the variables drop out. But when you work it all the way down as far as you can, then you either get something that's true or not true. You could also write this, okay? Questions on any of those?